Consider the points A at -2, 0, B at 2, 1, and C at 1, -3. Determine if the triangle is equilateral, isosceles, or scalene. So hopefully you know what these terms mean. I'll just go over them quickly. Equilateral means all three sides the same length. So you've got a triangle, every single side is the same length. All the angles are the same as well, but we're not really thinking about angles to solve this question. In an isosceles triangle, you have exactly two sides the same length. And in a scalene triangle, all sides are different lengths. So, what we're going to have to do is find all three lengths in this triangle. So we're going to need AB, AC, and BC. So probably we're going to need to know the distance formula. So let me write that down. So if we have two general points, the distance between the two equals, well, it's the square root of the difference between the x coordinates, so x2 minus x1, and then you square it, plus the difference between the y coordinates, y2 minus y1, and then you square it, and then you take the square root of that. This comes directly from Pythagoras' theorem. We're finding the long side of a right-angled triangle. Okay, so that's the formula we're going to use, and we're going to have to find all three lengths. So let's start with AB. So if we just sort of write this formula, sum of it, and then we can just fill in the blanks, it might be easier. So it's the square root of something minus something squared plus something minus something else squared. It's probably easier, and then you can just fill in the numbers. So the first bit is x2 minus x1 squared. If we're using AB, I'm going to use A as 0.1. So I'm going to, for this particular bit, I'm going to consider this is my x1, y1, x2, y2. Okay, so x2 minus x1 must be the x coordinate of B minus the x coordinate of A. So it's 2 minus -2. You do need to really be careful with some negative signs on here. Now for the y's, well it's y, the y coordinate of the second point minus the y coordinate of the first point. So that's going to be 1 minus 0. 1 minus 0 equals, well 2 minus -2 is 4. It's 2 plus 2, so it's 4 squared. Plus 1 minus 0 is 1 squared. So 4 squared is 16, 1 squared is 1, 16 plus 1 is 17, so it's root 17. And for this question, you're much better off leaving it in this form. I've got no interest in working this out as a decimal. It will not help you, and it will take time. So that's AB. Right, so now you can do BC or you can do AC. I'm going to do AC. I'm going to do it here. So AC equals, so square root of something minus something squared plus something minus something squared. So for AC, I'm going to use, for my x1, y1, I'm going to use point A, so x1, y1, and I'm going to use point C for x2 and y2. So for the x's, we need to take the x coordinate of the second point, well, we need the x coordinate of the second point take away the x coordinate of the first point. So that's 1 minus -2. 1 minus -2. For the y's, it's going to be -3 minus 0. -3 minus 0. So that is 1 minus -2 is the same as 1 plus 2, which is 3, and then we square it, plus, well, -3 minus 0 is still -3, and then we square it. So that is going to be, well, 3 squared is 9, and -3 squared is also 9, because we're told -3 times -3. 9 plus 9 is 18, so this is root 18. Might just box these so we don't lose them. And finally, we are going to do BC equals, so again it's something squared, something minus something squared plus something minus something squared. So for BC, we're going to use point B as x1, y1, and point C, x2, y2. So for the x's, we are going to do 1 minus 2. Remember, it's the x coordinate of the second point minus the x coordinate of the first, so 1 minus 2, And for the y's, it's going to be minus 3 minus 1. Minus 1. So that equals, well, 1 minus 2 is minus 1, so minus 1 squared, plus minus 3 minus 1 is minus 4 squared, which is, well, 1 squared is 1, minus 4 squared is 16, 1 plus 16 is 17, root 17. So now we have all three side lengths, let's change that 7. We have all three side lengths and they are root 17 for AB, and we have root 17 for BC, and we have root 18 for AC. So exactly two sides are the same length, so that means the triangle must be isosceles. So ABC is isosceles. And the reason being that exactly two sides are the same length. You could write down it's because AB equals BC, which equals root 17.